Good morning children. Let's continue with exercise 11.2 question number 8. Mohan wants to buy a trapezium shaped field. The trapezium I have drawn here. Its side along the river is parallel to and twice the side along the road. So let the side along the river be mentioned as the longer side and the side along the road, that will be the smaller one. What's the relation? Its side along the river is parallel to and twice along the road. So the parallel notation. So let the side along the road be x. Therefore the side along the river will be twice, means it will be 2x. If the area of the field is 10,500 meters square and the perpendicular distance between the parallel sides is 100 meter, find the length of the side along the river. So let's take it as, let the length of side along the road be x meter. Therefore length of side along the river will be 2x meter. Then height is given as 100 meter. Area of trapezium is given as 10,500 meters square. What is the area for trapezium? Area is equal to half into height into sum of the parallel sides. Let's substitute. 10,500 is equal to half into the height is given as 100, a plus b x plus 2x. 2, it is becoming 50. 10,500 is equal to 50 into 3x. 5 into 3, 15. So 10,500 is equal to 150x. X is equal to 10,500 divided by 150. Reduce with 5. 5 3s are and 21. So this is 7. So the value of x is 70 meter. So what will be the length of side along the river? Along the river is 2x, that is 2 into 70, which is equal to 140 meter. Question 9. Top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. So underline the word regular octagon. An octagon is a polygon of 8 sides. Since it is a regular polygon or a regular octagon, all the sides are equal. Regular octagon, it has 8 equal sides. And now see, the measure of each side is given as 5 meter. You have to find the area of this octagon. When you see the portion, we can divide into 3 parts. If you divide this octagon into 3 parts as shown here, and if you calculate the area separately and add them, you will get the area of octagon. It is made up of 2 trapezium and 1 rectangle. Let's find the area of the first trapezium. Area of trapezium 1 is equal to half into h into a plus b. Half into height is given as 4. The parallel sides, the one of the side is 11 and the shortest side is 5 meter because it is one of the sides of the octagon. It is 11 plus 5, which is equal to 2 into 16 as 32 meter square. So the same will be area of trapezium marked as 3 is also 32 meter square. area of rectangle. The figure marked as 2 is equal to area of a rectangle is length into breadth, which is equal to 11 into 5, 55 meter square. Therefore, what is area of the regular octagon here? Regular octagon is equal to 32 plus 32 plus 55, 64 plus 55, 5 plus 4, 9, 119 meter square. Question number 10. There is a pentagonal shaped park. Pentagon means again a polygon with 5 sides. For finding its area, Jyoti and Kavita divided it in 2 different ways. You can see, find the area of this park using both the ways. The area can be found out by 2 different methods. 2 persons are finding it out in 2 different ways. Let's see the answer for this particular question. You can see in the first case, this park can be divided as 2 trapeziums as marked here. Trapezium 1 and trapezium 2. Trapezium 1, if you consider, this is one of the parallel side 15. The another parallel side is 30. Height is 15 divided by 2 because the total length of the side is 15, which shows that half of 15 will give you height of the trapezium. So, like the first method, area of park is equal to area of 2 trapeziums. Since the areas are equal, we can only find the area of one trapezium and then multiply by 2, which is equal to half into 2 times half into h into a plus b, 2 into half into height is 15 by 2. Sum of the parallel sides 15 plus 30. 2 into half into 15 by 2 into 15 plus 30 is 45. This 2 and 2 gets cancelled, which is the same as 15 into 45 divided by 2. Let's see what is 15 into 45. 15 into 45. 7, 20, 2, 4 plus 2, 6. 675 by 2. 300 and 2 3s are 6. Again, 2 3s are 6. 7 2s are 14. So, 337.5 meter square. That will be the area of the park. Let's see by the second method. By the second method, it can be taken as area of a triangle plus area of a square. Area of park is equal to area of triangle 1 plus area of square, which is marked as 2, which is equal to area of triangle half into base into altitude plus area of a square is a square, half into base is 15. Now, the total from this vertex till the end is given as 30. One of the side is 15, which shows that height of the triangle is 15 meter. 15 meter plus side of the square is 15, that is 15 square. 15 into 15 is 225. 225 divided by 2 plus 225. This is 112.5 plus 225.0, which is 225.0, 112.5, 337.5 meter square. That is, area of the park can be found out by 2 different methods. Trapezium multiplied by 2, or it can be divided as a triangle and a square. Question number 11. Diagram of the adjacent picture frame has outer dimensions 24 by 28 and inner dimensions as 16 by 20. Find the area of each section of the frame if the width of each section remains the same. So when you see the picture, it can be treated as a trapezium. All the frame, the boundary will be looking like a trapezium, where the parallel sides, the longer side is 24. There are two similar ones, one on the top as well as below, and here 3 and 4, they are looking as the same shape. For the trapezium shaped with 1 and 2, let's calculate the area. The longer side is 24, shorter side is 16, very visible. And now to get the height of the trapezium, the outer length is 28, the inner length is 20, which shows that the difference is 8. That is, it has been divided as 4 and 4. So what is the height of the trapezium part? It is 4 centimeter. Similarly, for area of 3 and 4, the outer length is 24, inner length is 16. 24 minus 16 is again 8. The height is given as 4 and 4. So area of trapezium 1 and 2. A is equal to 24, B is equal to 16 and height is equal to 4. How did we get the height? It is 28 minus 24. 28 minus 20 is 8. That 8 centimeter we have divided for both the trapeziums. Each one height is 4 centimeter. Area is equal to half into 4 into 24 plus 16. That is 2 into 4 plus 6, 10. 2 plus 1, 3 plus 1, 4. Which is equal to 80 centimeter square. Similarly, let's calculate the area of trapezium 3 and 4. Base. Part of the base is 28 centimeter. A is 20 centimeter. And height, the same concept of 4 centimeter. Area is equal to half into h into a plus b. Half into 4 into 28 plus 20. 2 into 8, 48, which is equal to 96 centimeter square. So this will be the area of the edges of the frame. The next topic is on solids. What are solids? Something which occupies space are called as solids, and solids are always three-dimensional. The first solid is of cuboid. The clear example of a cuboid is a tissue box or matchbox or the geometry box. These are all clear examples of a cuboid. A cuboid, if you want to represent it, can be represented in this way. It has three dimensions of length, breadth and height. It's a three-dimensional picture. It is having length, breadth and height. A cuboid has 6 faces and the faces are all rectangular. It has 12 edges and it has 8 vertices. So a cuboid, there are 6 rectangular faces. Now, the area of one of the face is area of the base as well as the top. The dimensions will be L and B. So, it will be L into B. The area of 2 side faces, area of another 2 faces will be B into H with the dimensions of base and breadth and height. And area of another 2 faces will be LH. The example can be very well understood by using this tissue box. You can see it has a length, it has a breadth and it has a height. So area of the top as well as the bottom faces will be length into breadth. Area of the remaining 2 faces will be breadth into height, and area of this face will be length into height. So what is the total surface area of a cuboid? Will be 2 times LB, 2 times BH, 2 times LH, or it is 2 into LB plus BH plus LH. This will be the total surface area of all the 6 faces of the cuboid. Suppose you want to find only the lateral surface area, that is only the surface area which is in the side, by accepting the base and the top. What is the lateral surface area? You can avoid the base as well as the top. It is 2BH plus 2LH. That will be the lateral surface area of a cuboid. So the 2 formulas on surface area of cuboid is the lateral surface area is 2BH plus 2LH, which says that the base as well as the top portion has to be exempted, and the total surface area is 2 into LB plus BH plus LH. The second solid is a cube. How to represent cube? As it has 6 faces which are all square shaped. You can represent it in this way. If you join the vertices, this will represent a cube. The examples of ice cube or the dice you are playing with, dice or die we call, the plane you are playing with, all these are examples of cube. A cube also has 6 faces. All the faces are square shaped. There will be 12 edges and there will be 8 vertices. So if you can find the area of one face of the cube, and since it has 6 faces, the total surface area will be 6 times area of one face. Let's call the edge of the cube as it has length also A, breadth also A, height also A, or what will be the area of one face? It will be area of a square, which is equal to A square. Therefore, what will be the area of 6 faces? It is 6 times A square. That is the total surface area of a cube. So, total surface area of a cube is equal to 6A square. As I told you, if you exempt the top as well as the base, that will give you the lateral surface area or the surface area of 4 faces. So, lateral surface area of a cube is equal to 4 times a square. If you take all the 6 faces, that will give you the total surface area, and if you take the 4 faces, that will give you the lateral surface area. The third solid is cylinder, which has 3 faces, 1 curved face and 2 flat faces. A cylinder which has 3 faces, we call it as a curved surface. One of the surface is a curved surface, that is number 1, and the second and third face as 2 flat faces. Looking into the shape of the faces, first, to find the total surface area, we need to get the area of the curved face. For that, we say the cylinder as a hollow cylinder. Take the example as a hollow cylindrical shape here. You can see the hollow cylindrical shape here without the base as well as the top. And now, if you see the cylindrical shape here, the base shows the shape of a circle. Since it is hollow, this measure will be the circumference of a circle. What is the formula for circumference of a circle? Is equal to 2 pi r. When you cut open this hollow cylinder, it will take the shape of a rectangle, where the length of the rectangle will be the circumference and the breadth of the rectangle will be the height of the cylinder. Height of the cylinder. So if you can find the area of this rectangle, that will give you the curved surface area of the cylinder. Since it is a rectangle, area is the same as length into breadth, or it is 2 pi r into h, or it is 2 pi r h. So what is the curved surface area of a cylinder? The curved surface area of a cylinder is 2 pi r h. And now the flat surface, both the shape of a circle, area of one circle is pi r square. So there will be 2 surfaces of circular shapes, which shows that total surface area is the same as pi r square plus pi r square plus 2 pi r h. Pi r square plus pi r square is giving you 2 pi r square plus 2 pi r h. Or to study easily, let's take the common factors outside. 2 pi, one of the radius here, it is r plus h. So what is the total surface area of a cylinder? It is 2 pi r into h plus r, or 2 pi r into r plus h. So the lateral surface area or curved surface area, we call it as 2 pi r h, and the total surface area is 2 pi r into h plus r. The next exercise is based on the surface area. We'll do it in the next class.